ocean waves are one of nature's most awesome forces. However, there are those among us who willingly embrace that unbridled energy. Surfers. They know exactly when to jump onto their boards to catch the best rides. So how do they do it? For one thing, it's a matter of timing. And much of their success also depends on the elements. Primarily, wind. Most ocean waves are formed when wind blows across the water's surface, transferring the wind's energy to the water. A wave is the movement of energy through the water. Although a wave appears to carry water toward the shore, in actuality, the wave energy is moving forward, not the actual water itself. That's how surfers can bob along in the water, waiting for a breaking wave. Waves begin in the open ocean and break as they come into the shore, where the water becomes increasingly shallow. As the wave moves into shallower water, the lower part of the wave slows, while the top keeps moving forward. At a certain height, the crest, or highest part of the wave, topples over, and the wave breaks. Waves can vary in size depending on the power and duration of the wind that creates them. But big or small, waves are one example of how the ocean is a place of continual movement. What is the relationship between wind and waves? As you watch this segment, think about how waves, currents, and tides all illustrate how the ocean is constantly in motion. It can be said that all of Earth's oceans are one, a single salty liquid body that extends as far as the eye can see. Waves, currents, and tides are responsible for moving all this water in somewhat predictable patterns around the globe. And wind is a powerful force behind the movement of waves. Chief among the people who need an in-depth knowledge of wind and waves are sailors. These sailors are racing around the world and will spend several months braving the world's oceans and the elements. Needless to say, these experts have to know how to use wind and waves to their best advantage. That means knowing something about how the wind affects ocean waves in different parts of the world. For example, in the South Atlantic Ocean, extending south of the tip of Africa and South America to the border of Antarctica at 40 to 60 degrees south latitude, the wind blows with such strength that the region has earned the nickname the Roaring Forties. Sailors can get into trouble here, where the waves generated by wind transmitting its energy into the water become violent because there are no land masses to break up their energy. Wind is also a factor in the creation of ocean currents, another type of ocean motion. Currents are large streams of moving water that flow within the ocean. Currents operate at all depths of the ocean, but currents on the water's surface are the most affected by wind. They also move the fastest. In fact, when sailors encounter times of little or no wind, surface currents can carry them off course. Unlike waves, which transfer energy through water, currents actually move water. In doing so, they circulate heat and nutrients, affecting our global climate and enriching the ocean ecosystem. In general, currents circulate the warmer water away from the equator and bring cooler water toward the equator from the poles. A surface current can warm or cool the air above it, and, as a result, influence the climate of coastal regions. Currents will also transport just about anything that might fall in, including these rubber ducks. These scientists, Curtis Ebsmeyer and Jim Ingram, are studying ocean currents with the help of these bathtub toys. To better understand how the rubber ducks will float and travel in the ocean, the scientists simulate the conditions in a swimming pool. About 29,000 plastic toys fell off a container ship in the Pacific Ocean, a few miles off the coast of Alaska. As the shipment washed ashore all over the world, the scientists were able to use a computer model to chart the course of the toys and the currents they traveled on. To do this, oceanographers take into account wind speed and direction, waves, and other factors. But wind only affects ocean currents down to about 30 meters below the surface. Below that point, ocean currents are affected by the density of the water itself. Water density depends on pressure, saltiness, and temperature. Cold water in the polar regions sinks into the deepest parts of the ocean and moves toward the opposite pole. This displaces the deeper water, causing it to move. This movement is a deep ocean current. To map the deep currents, scientists use tools such as this tiny aluminum submersible called ALICE. As it descends to a depth of about 900 meters, it records information about temperature, saltiness, and water density. About once a month, the ALICE is brought to the surface to provide data that helps scientists determine how changing temperatures below the surface affect life above the surface. At the ocean's edge, we can experience another example of ocean motions: tides, the daily rise and fall of Earth's water on our coast. Tides are the response to the gravitational pull of the moon and sun. The moon exerts a strong pull on water and land. The effect of the moon's pull results in a visible sign: a high tide on the side of Earth facing the moon. The exact opposite side of the Earth will experience high tide at the same time. In places in between these two bulges, the water is at low tide. The sun's gravitational pull works in a similar way and can add to or subtract from the tidal influence of the moon. Waves, currents, and tides are different ways in which the ocean reacts to the forces around it. And these ocean motions have a powerful effect on our world. How is a wave different from a current?